Okay, class, moving on sa aton nga next chapter, we will be discussing sa aton na nga more on sa calculation na sa aton nga mga samples or sa imong mga nag-gathered nga samples. So, what are you going to do sa aton nga mga data nga na-achieve through your experimentations or after sa mga sampling. Up here, characterizing your measurement and also sa aton nga mga result. So let us begin by choosing a simple quantitative problem that requires a single measurement, okay, which is the mass of a penny. For example lang, so we'll be using here is ang penny. Penny is usually sa US states or din or for here you also have your mga coins, mga peso. Muna. So you have probably recognized that our statement of the problem is too broad. For example, are we interested in the mass of the United States penny or mga Canadian nga penny or differential relevance because your pennies nga composition and sizes differ from country to country. So let us narrow our problem to pennies halin lang sa US. Or for here's example sa Pilipinas, we will be using for example a 1 peso nga coin. So we will be collecting around kung dili nga example it used around 7 nga US penny. So what is the mass of the circulating US state penny? Here a picture of a US state penny. A good way to begin with your analysis is to gather some preliminary data. Okay, shows the mass of 7 pennies collected from a change jar. Okay, in examination of this data, we see that the question does not have a simple answer. Okay, that is, we cannot use the mass of a single penny to draw a specific conclusion about your mass of any other nga mga penny. Although we might reasonably conclude that all pennies weigh at least or 3 grams. We can, however, characterize this data by reporting the spread of individual measurement around the central na value. So you have here a table of all the 7 penny nga nakuha ya sa change jar. Therefore, ang iyang average or ang mostly nga weight sa mga penny is greater than 3 grams. So you have here the first penny weigh around 3.080 grams. You have your second penny weighing 3.094 grams. Third penny 3.107 grams. Fourth penny 3.056 grams. Then for your fifth nga penny, it is around 3.112 grams. For your sixth nga penny, 3.174, and for the last nga penny, which is 3.1998. For the measurement or the measures of your central tendency, one way to characterize the data in table 4.1 is to assume that the masses of individual pennies are scattered randomly around your central value that is the best estimated of penny expected or your true mass. There are two common ways for estimating your central tendency, okay? Is what you call your mean and median. So let us define each. Okay? For your mean niya class, okay, the mean, okay, it is, ang niya symbol is X with a bar line sa babaw. Okay, it is the numerical average of the data sheet. We calculate that the mean by dividing the sum of all individual nga values. You have here sa babaw, your 7 nga value. Okay, divided by the size of your data sheet. You have here the mass. Okay, ang total nga value, ito i-sum up nyo. Then, kung pila ka bilog as your size data. Then, you have here xi, okay, is the I measurement, and n is the number of your size data set. You have here the example or paano you can solve ang mean given sa imong nga table. You have here what is the mean for your data in table 4.1.1. Solution, calculate the mean. We add all together your result for all your measurements. So, i-add mo lang from penny 1 to penny 7. You have here penny 1, 2, 3, 4, 5, 6, and 7. Kaya ang total yung mass is 21.821 grams. Okay, then divide mo lang sa total numbers sa imo nga penny. So you have 7 as your total nga number. So 21.821 grams divided by 7, you will have the mean for your data for around 3.117 grams. So that is the mean of your measured data. Now, since may mean ka na class, okay, that means the most common estimate for central tendencies. It is not a robust estimate, however, because a single extreme value or one much larger or smaller than the remaining of your data. Okay, influences truly your means value. For example, if you accidentally record the third penny mass as 31.07 instead of 3.17 grams, okay, the mean changes from 3.117, which is the correct nga mean value, will be turned into 7.112 grams. Dapat, ang imong data collected is sakto. Okay? An estimate for a statistical parameter is robust if its value is not affected too much by unusual large or unusually small nga measurements. So, ang ilang nga data is relatively close to each other. Now, next is your median. Okay, a median is represented by an X and with, anong tawag sa baba man? Daw, console nga sign. Okay, in the middle value, we order our data from the smallest to largest. So, wala siya from your penny 1 to penny 2. Ibig sabihin, ang value arranging is from smallest value up to the highest nga value. So, you have here, magabalik na sa definition. Okay, when the data has an odd number or values, the median is the middle nga value. For that is odd. Okay, ano kaning odd? You have your 1, 3, 5, 7, 9, 11, 13. Okay, that's your odd nga number. And for your even naman yung class, you have your 2, 4, 6, 8, 10, 12, 14, 16, so on and so forth. Okay, for even values, the median is the average of the duwa ka number which is sa center and i-divide mo siya sa 2. I-add up mo ang duwa ka number, then divide mo siya sa 2. Okay, where n is the size of your data size. Okay, what is the mean or what is the median sa atong data sa table 4.1.1? Okay, solution. Ang first rule is i-arrange mo sila from lowest to highest. So you have the lowest value of 3.056, next 3.080, 3.094, okay, 3.107, 3.112, 3.174, and 3.198. So because pila ni sila kagabilog, this is 7 ka data. Therefore, it is an odd nga order. Kaya kung odd siya, isipon mo or pangitaon mo ang sa tunga nga value which is your 3.107. Okay, this is the middle value. Therefore, it is your median. Amo man lang naka simply. So for those nga nakaagi na statistics, so this is very easy para sa iyo. Okay, as shown sa atong example 4.1.1, example 4.1.2, and the mean and also your median provide similar estimate of your central tendencies with when all the measurements are comparable in magnitude. The median, however, is more robust estimate of your central tendency because it is less sensitive to measurements with extreme nga values. For example, if you accidentally record your third penny with a mass of 31.07 instead of 3.10 grams, for example, na same being error sa babaw, okay, the median value would change from 3.107 to 3.112 nga aman. Because kay kung i-change mo yung mga order, madula na yung sa tunga. So, maging 31 yung sabi, for example, sa laing mong pag-record. So, kay 31.07 siya. So, it is the highest value. So, dili mo na siya makita sa pinaka-right side. Okay, replacing the middle na nga value which is your 3.112 as your fourth nga value sa imong nga order. So your median now will be 3.112. Siya. Now, let us now proceed sa aton nga measure of your spread. Okay, if the mean or your median provides an estimate of a penny expected mass, then the spread of your individual measurement is about the mean or your median provides an estimate of the difference in mass among pennies or of any uncertainty in a measuring mass with a balance. Although we often define the spread relative to a specific measure of your central tendency, its magnitude depends on your central value. Although shifting all your measurement in the same direction or adding or subtracting sa ating constant nga value, okay, that changes your median or your mean. It does not change the spread. There are three common measures of your spread, which is the range, the standard deviation, and your variance. So, umpisahan ta sa aton nga range. Okay, the range, okay, sa yung symbol sa aton nga range is small letter nga W. Okay, it is the difference between the data sets pinakataas, which is your largest, and your smallest nga value. Okay, the range provides information about the total variability in the data set but does not provide information about the distribution of your individual value. Therefore, the range for your table or sa atong nga sample, which is sa atong nga table 4.1.1 is you have the highest value of 3.198 grams. We have here the highest value and the lowest value of 3.056 grams. Therefore, i-subtract mo lang. Ang imo nga range sa amo na nga sample or sa amo nga table is 0.142 grams. Mumalan na ka simply ang atong range. It is highest minus your lowest available nga data. Now, for aton nga standard deviation. Standard deviation is quite complicated kung di ka kabalo magtanaw sa aton nga formula. For standard deviation, it is a small letter S. It describes the spread of an individual value about their mean and is given as, you have here a total, okay? This is for your initial minus your mean squared minus the total your value, which is, for example, Dina, you have your 7 na sample minus 1. Okay, where x is one of the individual values in your data set and x is the data set mean value. Frequently, we report the relative standard deviation as your SR, okay, ang imo nga relative standard deviation instead of your absolute date or absolute standard deviation. And also you have your percent relative standard deviation, which is your SR is times mo lang siya sa 100. So the relative standard deviation is important because it allows for more meaningful comparison between the data from each other when individual measurements differ significantly in your magnitude or sa ilang nga value. Considering again in aton nga data, for example sa penny, if we multiply each value by 10, the absolute standard deviation will also increase by 10 as well. The relative standard deviation, however, will be the same. So, report sa aton nga standard deviation, okay, is the relative standard deviation kag ang iya nga percent relative nga standard deviation for your data. Okay, how do we get your standard deviation? Okay, to calculate the standard deviation, first you need to calculate the difference between your each measurement and your data nga mean value. Okay, first you have your first nga penny, which is your 3.08 80, okay, minus your mean. Kaya mo natin mean, which is your 3117. Kita tayo na sa babaw. Yeah. Okay, this is your mean, di ba? Balik tadi. Mean. Then, i-square root mo man lang na. So, you have 3.080 minus 3.117. Because you have a higher value sa inyong mean, so your answer will be negative. So, it is negative 0.037. Then, it is in square. Sabihin, multiply mo na sa young self, giving you an answer of 0.001369. And for your second na value, which is 3.094 minus 3.117, we'll have negative 0.023 squared. Multiply mo siya self, you will have 0.000529. And third nga value, you have third nga penny, 3.107 minus 3.117 will have a value of 0.010 squared. Multiply mo siya nga self, the answer is 0.0001. Okay? And you have 3.056 minus 3.117. It is 0.061 squared. And for your square root yang or square yang value is 0.003721. Next, you have 3.112. Okay? Ang yung answer minus yung mean is 0.005 squared. Is negative nga value kung mas nubo gyapon ang value sa imong penny. Then, ang iyang answer kung i-square mo na siya is 0.000, apat ka 0, 2, 5. Then, 6 nga penny, which is 3.174. So, it is higher than your mean na 3.117 is equals to positive 0.057 squared. Okay? Then, yung value is 0.003249. And you have your 7th nga penny, which is 3.198 minus the mean of 3.117 squared is equals to positive 0.081 squared. Square mo siya, the value will be 0.006561. Now, for those nga basig sa lagyapon nga wala na ni siya nag-negative, because if you are given with a negative value, kung i-multiply mo man sa siya nga self or sa same nga negative man nga value, it will result into a positive nga value. Okay, reminder lang ha. Now, i-total up mo na sila because you have here sa imong equation, it is the sum of all the values ng imong nga standard deviation. Then, ang mga total is 0.015554. Okay, that is the total of your na SD mo nga mga value of your individual pennies. Then, for your N, okay, the N is the number of data you are using. Because you're using 7, okay, your N is 7. Okay, hindi na sa hindi na sa constant class. So, if you're using 8 ka data, so it will change into 8. Ano na? Klaro? Now, because 7, then you have here minus 1 for your SD. So, it will be maging divided by into 6. So, it is 0.015554 divided by 6. Then, i-square root mo yung value. The answer is 0.051 grams. Now, because you already get the standard deviation, you will go or proceed sa aton nga na relative standard deviation. Okay, your relative standard deviation and also percent relative standard deviations are, for SR, it is equal to your SD or standard deviation divided by your mean. Okay, your mean is 3.117. So, that is your relative nga standard deviation. So, it is 0.016. Okay, now for your percent na yung class ng imo nga relative standard deviation, use the value of your relative standard deviation, i-times mo man lang siya sa 100. So, kung para sa shortcut, pag hindi ka na magamit calculator, simply move it 2 ka beses ang imong decimal point paadto sa left side. Now, it will give you your percentage nga value, which is 1.6%. It is much easier to determine your standard deviation using a scientific calculator with a built-in statistical function. So, sa mga wala scientific calculators, you will be doing this manually. Now, for your variance na, okay, variance or another common measure for your spread is your variance, which is the square of your standard deviation. We usually report your data set or your standard deviation, rather its variance, because the mean value and your standard deviation share the same unit as we will be seeing sa aton nga mga examples sa dalog. Okay, the variance is useful measure to spread because its value are additives. So, I have here an example. What is the variance sa aton man nga data or sa aton nga sample about your pennies? Okay, the variance is the square of your SD. What is your SD? The SD is 0.051 grams. Ang muna na. So, square root mo lang. Grab here. Variance is the square of your absolute standard deviation. Using your standard deviation for your example gives us your variance or equals to 0.0026. That is now your variance. Okay. Next nga example. Okay. Because you already used penny. So we'll be using now is your sodium nga. Okay, sodium in your serum. Okay, concentration of your sodium or Na plus or Na ions in a mmol per liter or millimole per liter. So you have 140, 143, 141, 138, 132, 138, 137, 132, 157, 143, 149, 118, and 145. So, pila ka bilog yung mga values. So, importante na sa nga daat. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You have 10 data set. Okay? Report the mean, median, range, standard deviation, and also ang imo nga variance. Okay, this data is proportional for the larger data set with your Andrew. Okay, this is the source. Now, answer. For your mean, simple lang ba aton nga mean? Mean is the total of all value. Then, i-divide mo lang siya sa total mo nga sample data sheet set, which is 10. So, 140 plus 143 plus 141. Okay? Plus 138, 37, 132, 157, 143 plus 149 plus 118 kag 145. Okay? Kay total mo na, it will give you a sum of 145. Ay, hindi pa. 145 yun man. Then, i-divide mo pag isa sa 10. Therefore, it will give you the mean of 140.5. Okay? So, kagin, ano niya pa gid, gin standard, again, scientific notation niya pa. Okay, your scientific notation is, ginapalasan mo yung mga value, which will turn this into 1.40 times 10 raised to 2. Okay, millimoles per liter. Now, for the median niya class, okay, median is i-arrange mo ang imutanan nga value from your lowest to highest. So, what is your lowest? The lowest is 118. Next, followed by your 132, 137, 140, 141, 143, 143, 145, 149, kag 157. So, kung may mga identical nga numbers, same sa mga 143, okay, kaduwa siya nagguwa. So, you have 143, 143. So, ang median mo, kung even ganun, di ba class? If you have even, so, ang pinaka middle nga part, which is the middle nga part is your 141 kag 143. So, i-add mo na ang duwa mo nga value, then i-divide mo siya sa 2. Therefore, ang imo nga median is 142 millimole per liter, or kung i-scientific notation mo, it is 1.42 times 10 raised to 2. Now, for your range naman niya class, simple lang ito nga range, it is the highest value minus your lowest value. So, the range for your example or sa atong exercise here is 157 minus 118. Therefore, ang imong range is 39 millimole per liter. For standard deviation naman, okay, direct calculate yan nga daan. It is that every value, okay, minus your mean. Okay, your mean is 140.5. Then, square root mo yung mga value. Okay, this is all the value that you can gather. Then, the square difference are, okay, gin-square yan ha. So, we have 0.25, 6.25, 0.25, 12.25, 72.25, 272.25, 6.25, 72.25, and 506.25, lastly is 20.25. Ang imong total, okay, the total value sa babaw, okay, is 968.50. Then, i-minus mo sa total set minus 1. I-minus mo sa total set. I-divide mo sa mga total set minus 1. So, you have 10 na total ng mga values mo. Minus 1, which is now your 9. And it will give you the square root nga value or 10.37. Kung i-round off mo into 1 decimal place, the SD or standard deviation is 10.4. Now, for your variance na yung class, okay, simply square root or 8 times mo lang sa yourself ang imong value. The variance is the square of your standard deviation or 108. Okay? It is very simple kapina kung nakaagi ka na sa ito nga statistics. So that will be all sa chapter 4 and see you on sa aton nga next nga topic.